Hello everyone. So now we will be solving the second problem of the contest, which is aggregate two time series. So this is a bit relative easy problem as it's the second problem of the contest. So let's first read the problem statement. The problem states that you are given two 2D integers, series 1 and series 2. Each element in both series is of the form timestamps, comma value, where timestamp is an integer representing that time. Value is an integer representing the value at that timestamp. Okay. Each array is sorted in strictly increasing order of timestamp. Now, this line itself gives a brief hint of which direction should you be thinking of. Let's first read the problem statement first, then we will be continuing forward. So, for any timestamp not present in a series, its value is taken from the next available timestamp in the CM series if one exists. Otherwise, its value is considered to be 0. Aggregate series is formed by summing the corresponding values from both series at every timestamp that appears in either of the series. You need to return the aggregated series, right? So the description itself is a bit clumsy, right? Means when you read it without seeing the test case, it is a bit difficult for anyone to understand, right? So let's first see what the problem states, right? Really sorry. Yeah, let me increase the size of it. Great. So what the problem state, the first hint, the problem when you read the problem that you should get, like how I will be telling how should you approach the problem, not just the solution, right? So the problem states that the array is strictly increasing, right? This alone gives you a hint that hey, you don't need to search any element if you want in that array from start to end. Instead, you can use binary search on that, right? Now this is very beautiful hint, right? Whenever you get an array which is strictly increasing, decreasing, or the array is monotonic, right? Monotonic means either it's strictly increasing, either it's increasing, right? Increasing after like this, anything, binary search will work on that, right? So let me use this. So this was the first hint that directly says you that you should be thinking in some of that direction, right? Great. Now let's look at the test case so that we can understand what the solution wants from us. So let's, when you see this one has a value of 3 in this. If this has a value 3 in this, you also need to find the value of 1 in series 2. What is the value of 1 in series 2? There is no 1 man. So the value of 1 in series 2 will be 2 itself, right? Great. You will go on the next element. It says 4 has a value of 1. You will say, okay, 4 has a value of 1. What is the value of 4 in this? Hey, there is no value of 4. So you will say 4 has a value of 2 because 4 greater than 4 is 5 and it has a value of 2. Yes or no? So you will mark 2 here, right? Then you will go on series 2. You will see, hey, 2. So you will say 2 has a value of 2. You will go in series 1 and find 2. You will not find 2. The value which is greater than just 2 is 4 and it has a value of 1. So you will say 2 has a value of 1 in this. You will go on 5. 5 has a value of 2. You will go in series 1, find value which is just greater than 5 and hey, there is no value greater than 5 or equal to 5. So you will say 5 has a value 0. So this is the whole thing which comes under the picture, right? Now 1 will give you a value, summation of the values from series 1 and series 2, which is 3 plus 2, 5. 4 gives you a value of 3, 2 gives you a value of 3, and 5 gives you a value of 2, right? You need to sort these values, right? Means first comes 1 comma 5 is your answer, 2 comma 3 will be second answer, 4 comma 3 will be your third answer, and 5 comma 2 will be your last. So you need to return this as your answer. Yes or no? If we look at it, this is the solution for this, right? Great. So let's look at the time constraint of the problem. The time is series dot length can be till 1e5, right? So n is till 1e5, right? So what can you think of? You need to write a solution which is big O of n or big O of n log n, right? You shouldn't be exceeding these values. Yes or no? I hope till this point everything is clear to you, right? Now let's move forward and think how can we create a solution, right? So my first claim or my first observation was using binary search, right? Now why we will use binary search? Let's say we have an element x which has a value val, right, in my series 1, right? Then what I will do is I will simply mark that value. I will say map of x will be equal to value 1. Let's call this as map 1. We'll have a value 1, right? For the same value, what I will do, I will search it in my series 2, that is x. Series 2, I will search for x, right? If I get x, then that is very good. Then I will simply do map of x equal to whatever the value which was written over there, right? Let's call that as val 2, right? Great. What if I don't get that val x? Then I will get something greater than greater than x, just greater, right? Just greater than x. If I get that, still I can, let's say that value was also val2, then I can also say that, hey, map of x will be equal to val2, right? How can I get the value just greater than x? We can use the function called lower bound, right? I hope you know about lower bound. What it does is, let's say if I have a value 1, 3, 5, 11, right, and my x is equal to, let's say, 4. So when I do a lower bound, it finds the value which is greater than equal to 4. If there is no 4, it will give my 5 as my index, right? Let's suppose there was a 4 in it as well, then lower bound will find the 4 in it as well, right? So it will return this index in this case, right? So I hope the formulation of lower bound is clear. So what we will do, we will find just element which is just greater than equal to x, right? Let's say if we don't find value which is greater than equal to x, then what we will do, we will simply say, hey, put that value as 0, right? Because there is no element which is just greater, so you can mark it as 0, right? So this was the whole crux of the problems or the solution. We will be doing it for series 1 for the first time, and then we will be doing for it for series 2 for the second time. Let's look at the code, right? Or rather, let me explain it one bit more specific. What we will do, we will run a for loop, right? For series 1, we will mark as map 1, and we will search in which map? We will search in which series? Series 2, because search series 1 is already marked in map 1, right? So now we need to search in series 2. Yes or no? Does this make sense to you? If yes, please do drop a like, right? And again, we will run again a for loop which runs in series 2 now, because series 2 might have some elements which series 1 didn't have, right? For instance, in this case, if you look at this, series 1 had 1, 4, and if you look at series 2, there is no 1 and 4, right? Similarly, in series 2 you had 2 and 5, but in series 1 you didn't have 2 and 5, right? So you need to run two for loops. After completing one for loop, this takes big O of n time. After we complete this again takes big O of n time, and in this we will search in series 1 the values which are there, right? So that is the whole crux of the solution, right? So let's look at the solution, right? First we will look at the code, and then we will do a quickly dry run on it as well, right? Great. So what I'm doing is I'm first creating an unordered map, right? We will run it for the example 2. So we are creating an unordered map, right? Map 1, map 2, and we are running on all elements till n1, right? Both have same size. While that I was giving it at the time of contest, I created 2n. I don't know why. Yeah, so index 1 is series 1 of 0 and val is series 1 of 1, right? I will say map 1 of index 1 will be equal to val 1. Yes or no? What we are doing, let's say we had a value. Let's do it side by side, right? Let's take the value this, right? So what we are doing, we will say 1 has a value of 5, right? So map of 1 has a value of 5. Great. Then what I'm doing is I'm finding the int index. Int index is equal to where is the value which has which is the lower bound of the same value, right? So this is the lambda function which helps us find the value for val1, right? So we will be taking lower bound and we will be taking val2 as our value, right? So this will return us a index where the value is just greater than equal to 1, right? For in series 2 you will see 2 will be the value, right? So map of 2 will have a value of 1, which will give you a value of 2. How did we find that? We did an lower bound on this, right? Lower bound on the value 1, right? When you do the lower bound on value 1 in series 2, right, you will find the small value which is just greater than equal to 1 is 2, and it has a value of 2. So we'll mark map of 2 has a which has a value 1 gets a value of 2. Yes or no? Is this part clear to you or not? Right? Then we will move on the next index. We will get 3. Right? So what we will do? We will say map of 1 with a number 3 has a value of 1. Right? And map of 2 with a number 3, we will find what is its value. So we will do again a lower bound. On 3, you won't find any element which is just greater than equal to 3. So you will mark it as 0. Great. Okay. After completing this, the loop has over. Now we will go on series 2, right? So series 2, we will find the first index. Let's see, we are doing the same thing, right? See, if index is equal to n2, means you are at the end of the index, then you can simply add it as 0 because there you haven't found any element, right? Else you will do the value, whatever the value was present at that very index. Yes or no? Does that make sense to you? Great. Then again we will run a for loop which is for series 2. We will find the value, we will add it in our map, right? After adding it in our map, I will say int index is equal to, again I will find the lower bound of that value, right? For instance, series 2 goes, we say map of 2 has a value of 2, at the value of 2 gets a value 2. Yes or no? Timestamp 2 value 2, right? Then we will find the lower bound which in series 1, where the value is 2, we get this as the lower bound, and this value is 3, right? Or 1 rather. So I will say map of 1 with a value of 2 gets a value, with a timestamp of 1 2 gets a value 1. Is it making sense to you? Great. So now after this, what we will do, we will simply add these values. So map of 1 will get a value of 7, map of 3 will get a value of 1, map of 2 will get a value of 3, right? That's it. That's a solution, right? So we are storing these values, and after that I will simply traverse on map 1, or you can traverse on any map. You will find index, you will find value. From it.first we will get the index, it.second we will get the value, and val2 will be from map of 2, right? Map of 2 index will give you the val2. Like when you do map of 2 3, you will get this value. Map of 1 3, you will get this value. Yes or no? I hope this is very obvious to you now, right? So now what I will do, I will simply push those values in our answer vector. Answer of index comma val1 plus val2, the summation of those values. We will simply sort it and return it, right? So you saw that in this case we have 1 comma 7, 2 comma 3, 2 comma 3. See, 2 has a value of 3, and 3 comma 1, 3 has a value of 1. Yes or no? So this was a solution for this problem. If you have any doubt in the problem's solution, you can definitely ask in the comments. The time complexity for this problem is big O of n log n, because we are doing a binary search for finding the lower bound of element and sorting the answer as well. So the time complexity will be big O of n log n, right? We are running it 2 times, but it will be n log n plus n log n again, right? So it ultimately boils down to n log n only, right? I hope that does make sense to you. If yes, please do give a like. If you have any doubts, do ask in the comments. No doubt is small or great. Every doubt is respectable, so you should definitely ask a doubt in comments. If it was helpful for you, do give a like and subscribe as well. Thanks for watching.